In this segment, we're talking about some theorems corresponding to eigenvalues and eigenvectors. And one of the theorems says that if lambda 1 up to lambda n are eigenvalues of a n by n A matrix, so you have a square matrix which is n by n, then you can find that the determinant of A, the absolute value of determinant of A, will be equal to the absolute value of the product of all the eigenvalues. So in order to find the magnitude of the determinant of A, all you have to do is you take all the eigenvalues, find the product of those eigenvalues, and you will get the determinant of the matrix A, the magnitude of that, which can be also written as this: I is equal to 1 to n lambda I. Which also now lets us make sense out of one of the theorems that if one of the eigenvalues is 0, then the A matrix is not invertible, it's singular, inverse cannot be found, which makes sense because if one of the eigenvalues is 0, then the product of all of these is going to be 0 irrespective of what the other eigenvalues are. Then the magnitude of determinant of A is equal to 0, which means the determinant of A is equal to 0, which basically means that the A matrix is singular. So that's just another way of proving that particular theorem. But let's take an example and see what we mean by that. So if somebody says that, hey, I'm going to give you an A matrix as this: 2, minus 3.56, 3.5, 5, 2, 8, 1, 8.5. And they're also telling you that, hey, I'm giving you the eigenvalues of this square matrix: minus 1.547, and then the other one is 12.33, and the other one is 4.711. Can you find the magnitude of the determinant? And you got to say, yes, I can find the magnitude of the determinant because I know that the magnitude of determinant of A is nothing but the absolute value of lambda 1 times lambda 2 times lambda 3. It's the absolute value of the product of the three eigenvalues. So this will be minus 1.547, 12.33 multiplied by 4.711, and this number here turns out to be 89.88. So that's the magnitude of the determinant of A, which basically means the determinant of A is either minus 89.88 or it's plus 89.88, but you are able to find the magnitude of the determinant, which might be the most important thing to find in most cases. And that's the end of this segment.